Alright, so this is a selection of problems from lesson 3.2 in our chemistry intermediate textbook. Now, we started these in class and some people had trouble, so I thought I would do a video to kind of walk through some and help you out. So if we're converting 128 milliliters to liters, the first thing we need to remember is that milli means 1,000. So 1 liter is 1,000 milliliters. Okay? So each milliliter is 1,000th of a liter. So we're going to set this up by saying 128 milliliters over 1. And we're going to multiply that by a conversion factor. Our conversion factor has to have milliliters on the bottom and liters on the top, because we want the milliliters to cancel out and we want to be left with the liters. Now, 1 liter is the whole and the milliliters are the fraction. So in 1 milliliter, there's 1,000, in 1 liter, there's 1,000 milliliters. All right? So we cross out the milliliters. We take 128 liters, divide it by 1,000, and our answer is 0.128 liters. So we can see that 128 milliliters is 0.128 liters, and this makes sense because if we instead say that 128 over 1,000 or 1,000 of a liter, okay, then that would also be 0.128 liters. All right.
So this is another conversion problem. This time we have our starting number in scientific notation, and we're going from micrograms to grams. So the first thing you need to know is that 1 gram is 10 to the 6 micrograms. But you could also say that 10 to the negative 6 grams is 1 microgram. Okay, they're both work. So just remember that micro means 1/1,000,000th of something. Okay. So if you start with 1 gram, then you're going to have 10 to the 6 millionths of a gram, or 10 to the 6 micrograms. If you start with 1 microgram, then you would have 10 to the negative 6 grams, because you only have 1/1,000,000th of a gram. All right, so here we set up our problem. We start with what we have, 2.5 times 10 to the 5th micrograms. Now remember, 1 gram is 10 to the 6th microgram. So we have less than a gram that we're starting with. Well, less than 2.5 grams. So we know micrograms have to go on the bottom because we want them to cancel. All right, and so that should be 1 gram is equal to 10 to the 6th micrograms. All right, micrograms cancel out, and we're left with 2.5 times 10 to the 5th grams divided by 10 to the 6th. All right, 5 minus 6 is -1, so our answer is 2.5 times 10 to the -1 grams. Now, as I mentioned, you could also do this from the perspective, so to speak, of the microgram. Okay, so this makes sense because 1 gram is 10 to the 6th. So if that was 2.5 times 10 to the 6th, then we would have had 2.5 grams. but since it's 10 to the 5th instead, we know that we have less than 2.5 grams. Now here, I'm just going to work it out with that other conversion factor. So instead of saying 10 to the 6 micrograms, I'm going to say 10 to the negative 6 grams is 1 microgram. My micrograms still cancel out. Since I'm multiplying my exponents, I'm going to add those together, and 5 plus negative 5 is still negative 1. Right. Next problem here, we have 2,800 cubic centimeters, and we want to convert that to meters cubed. Right. So we have 2,800 cubic centimeters. We need to convert that from centimeters to meters. So we're going to use the 1 meter equals 100 centimeters, but because we're talking about cubic centimeters, we're going to have to cube that conversion factor. Our centimeters cancel out. And so we're going to multiply across the top 2,800 times 1 meter cubed divided by 100 centimeters. All right, so we cubed our conversion factor. 1 cubed is 1, meters cubed is meters cubed, and 100 cubed would be 110 million? No, it would be 1 million, because it'd be 6 zeros. Okay. And so now we just have to divide. And here I'm just showing you the math if you want to see it. So 100 times 100 would be 10,000. And then multiply that by 100, you're just adding 2 more zeros. Okay? So we're going to move that decimal for each of those zeros in the denominator. So we're going to end up with 0.002800. Alright, those trailing zeros kind of don't matter, but they're a placeholder, so I'm going to include them. To put that in scientific notation, we'd have 2.8 times 10 to the third. So we have to move the decimal 3 spots to the left. It's going to be negative 3 for the exponent. Alright, so with this problem, we have 60 miles per hour, and we want to convert that to meters per second. Alright, so we're going to set up our conversion factor. We have our derived unit, 60 miles per hour, times 1,608 meters per mile, right? Times 1 hour per 60 minutes, times 1 minute per 60 seconds. Minutes cancel, hours cancel, miles cancel. So when we're done, we'll be left with meters and seconds. Alright, so now we're just going to multiply across the top. We have 60 times 1,608 times 1 times 1. Okay, we don't really need the ones because they don't change anything. On the bottom, we have 1 times 1 times 60 times 60. Again, the ones don't change anything, so we don't really have to show them. 60 divided by 60 is 1, so we can cancel that out. That leaves us with 1,608 meters divided by 60 seconds. This So now we have 3.20 centimeters times 4.90 centimeters times 5.40 centimeters. So this seems like we measured length times width times height. We're going to multiply all these together, and then we're going to have centimeters cubed, or cubic centimeters. So we're finding volume at this point. So the volume is going to be 84.672 cubic centimeters, or centimeters cubed. Okay. Now, that's my volume. the question tells me that the mass is 235 grams. Okay, so now all we have to do is calculate the density. Density, as we know, is mass divided by volume. So 235 grams divided by 84.672 cubic centimeters is equal to, again, we're going to bring out our old friend, the calculator. All right, and that gives us an answer of 2.78 grams per cubic centimeter. And that's all, folks. I hope this helps.